Hey everyone, welcome to AP Calculus AB and BC course, and in this session we are going to start with Unit 1, which is limits and continuity, which weighs 4 to 7% for the BC students and around 10 to 12% for the AB students. And in this session I will start with this topic, limits and continuity. So if you want to book a free demo or you need regular sessions or group sessions or one-to-one tutoring, you can contact us via this number using the WhatsApp or the Telegram. Okay. So let's start with limits and continuity. We have the following subtopics in this limits and continuity, like introduction to the calculus, limits and its definition, finding the limits using the graph or using the tables, or some analytic methods are also there by which we can find the limit of a function. After that, we have the continuity or the points of discontinuity. How can we can make the discontinuous function to the continuous function if we can do that, or removing, which we also call removing the discontinuity, and intermediate value theorems and so on. Okay, we have these many topics in this limits and continuity topic. So let's start with limits part. Consider that x and y are equal. Okay, these are two numbers and these are equal. X equals to y. You have to find the mistake here. Okay, I'll write something and you have to check whether this step is correct or not. So let's multiply both sides by 3. So yes, I can always do that. I can, because there is equality sign, I can always multiply by the same number. That will not affect my answer. I can write this 3x as 2x plus x and that 3y as 2y plus y. Okay, now it is also same, right? So let's bring this 2y to the other side. So I can write 2x minus 2y equals y on the same side, take this x to the other side. Can you see that? Sending this x to this side and 2y to this side. Now 2x minus 2y, let's take out 2 common. I get 2 times x minus y equals, take out negative sign common. So can I write it negative of x minus y? Right? Now you can divide both sides by x minus y, right? So let's do it. 2 equals negative of x minus y over x minus y. So if I cancel out these, I'll get 2 equals negative 1. Is it right? Can you see that? 2 equals to negative 1. Is it true? Obviously, it's not true, right? It is false. But what's the reason? We did it correctly. All the steps are correct. Like, yes, we can multiply by the same number. Yes, we can rewrite it like this. And we can take the terms to the left or right by changing its sign. Then what's the problem? You can pause the video and think about it. And I'm giving you the answer to this one. The reason behind this is that when we divided this by x minus y by x minus y, this portion, here we have the problem. The reason is, what is x? X and y both are equal. So can I say x minus y is what? 0. So if x minus y is 0, it means we are dividing 0 by 0. This is 0, this is 0, and we cancelled out these and we said it is 1. Wrong. That's not true. We don't know what is 0 by 0. See, if you have a number and any non-zero number, if you divide it by 0 even with your calculator, it shows you not defined, right? Because 1 over 0 is a very, 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 very large quantity which is tending towards infinity, I can say, right? So, tending towards infinity. But if you have denominator uh, as a finite number and numerator as 0, let's say 0 over k, where k is any non-zero number. So this number always gives you 0. So the problem is, what will happen if both numerator and denominator become 0? What can we do? If denominator is 0, answer tends towards infinity. If numerator is 0, answer is equals to 0. So what's the problem? What can we write here? So here is the point. These are indeterminate forms. Actually, this 0 by 0 is not 1. You cannot cancel out this. Okay? This step will be wrong otherwise. So these are indeterminate form. Not only this, we have total 7 such indeterminate forms like 0 by 0, infinity by infinity, 0 times infinity, infinity minus infinity, 0 raised to the power 0, infinity raised to the power 0, and 1 raised to the power infinity. These are 7 indeterminate forms. Okay, 7 indeterminate forms we have, means if we get answer from in any of these form, we say we cannot determine its value, and in that case we will try to find the value in its neighborhood, not exactly at that point. We will try to find the value in the neighborhood of that point. That we will discuss. That is the main point of this concept of limits. Okay, so note down this thing. Let's start with the limits portion now. Consider that you have a function fx equals 3x x square minus 3x minus 4 divided by x plus 1. Now, can we find the value of f of 1? Yes, simply, right? We can find f of 1 by substituting x equals to 1. So, we got 1 squared minus 3 times 1 minus 4 over 1 plus 1. What's that? Simple. This value comes out as 1 minus 3 minus 4 over 2. And on simplifying it, we got its value as minus 6 by 2. So, minus 3. Okay. So, we got this value as negative of 3 over here. But can we do it using our graphic GDC also? Yes, we can. We can simply draw the graph. Yes, from here also we can verify our answer. I'm using x equals to 1, right? And I got that y equals to negative 3. Yes, it is obvious. So, for that, look into the graph, please. And from the graph, if you go to x equals to 1, you will reach at this point and you got this point as your answer. So yes, we can do it by this analytic method, or we can do it by graphical method by drawing the graph also, right? So now let's find the values of say f of 2. F of 2 from the graph. We can do it by substituting x equals to 2, or we can do it from the graph. If I take x equals to 2, yes, I'll reach at this point here. What is that? Negative 2. So yes, my value will be negative 2 at this point. So simply put negative 2 over here. Let's say we have to find f of 4. What is that? From the graph only, let's say. So from the graph, you see, the value comes out as 0. Y value is 0, right? If x equals to 4. That represents this point, which is 4 comma 0. So I can write here 0. Okay. Now, let's find the value of f of negative 1. What is that? Can you find that value from the graph? X equals to negative 1. You will see over somewhere over here. What is that? Is it negative 5? Hmm? That's the question. Is it negative 5? From the graph, yes it is. Let's do one thing. Let's plot the graph of this function. Okay, x squared minus 3x minus 4 over x plus 1. And let's try to find the value of the same function on the x equals to minus 1 point here. If I keep zooming in, here you see, I'll keep zooming in. I'm trying to find the value. As you can see, when my number is approaching to negative 1 either from the left or right, my answer is also always approaching towards this negative 5. Okay, but let's zoom in. If I keep doing it, now here you can see it is showing a right this type of nature. What can you say? At x equals to minus 1, is it taking one value or various values, or what's the problem? Actually, at this point, there is a gap. I'll show you with the analytic method also. See, here directly substitute x equals to 1. What do you get? You will get negative 1 squared minus 3 of negative 1 minus 4 over minus 1 plus 1. So what is that? In the numerator you are getting 0, in the denominator you are getting 0. Indeterminate form, we cannot determine the value at this point only, right? So here is the concept of limit. If we are not able to find the value at that point only, we will take the value in its neighborhood. Okay, so for this function, we are not able to find the value at exactly negative 1, but by looking at the graph, you can see it is almost negative 5. Right? So from the graph, you can find the limit of a function using this. So here we can also use it like limit when x approaches to negative 1 for this function f of x, the answer tending towards what? Negative 5. That's how we represent the limit of a function fx tending to this negative 1. Okay, so from the graph we got this value. It means fx at x equals to minus 1 is not exactly minus 5. It is a number which is approaching to minus 5. And in this case, you can see either you go from the left or you going from the right. In both ways, you are reaching at this minus 5 only. Okay, so let's do it using the tabular method also. Consider this. I'll take different values of x. Okay, and let's find the value of y. What I'm doing? Actually, here I'm starting from this negative 1.1, and you see I'm approaching towards negative 1. So what I'm doing, if you keep zooming in here, I'm starting from this side, moving towards negative 1, right? So in this way, actually, I'm starting from the left side. So the value that I'm going to get from here will be our left hand limit. So this value will give me the left hand limit at minus 1. This raised to negative, this symbol is representing it's a value which is slightly, right? Slightly less than this negative 1. Okay. So fx, yes, we can do it using, you can use your GDC or spreadsheets to get these values, right? So when you fill these values in the GDC, you will get the points as negative 5.1, negative 5.01, negative 5.01, and so on. When you do it for a very close to negative 1, its answer is very close to negative 5. Similarly, you can do it by moving towards this negative 1 from the right side point. That we call right hand limit. Okay, it means I'm starting from negative 0.9, negative 0.99, negative 0.999. It means I'm approaching towards the negative 1 from the right side. Okay, so this negative 1 plus represent, it is a number which is very close to negative 1 from the positive side. Means it is just more than negative 1, just more than negative. Okay, so here if you substitute this value in your GTC, you can find the value of the function. So that comes out as negative 4.9, negative 4.99, negative 4.999, and yes, here you can see my answer is tending towards negative 5. Okay, so here when I reaching that number from the left side, we call it left hand limit, and it is represented by limit x approaches to negative 1 for the f of x, which is coming out as what? Negative 5 in this case. Similarly, I can do it for the right hand limit part. So I'll write limit x approaches to 1 plus minus 1 plus, which comes out as negative 5. So here you can see both left hand limit and right hand limit are approaching towards the same number, negative 5. So in this case, we say limit exists at that point. So please make a note of this. If the left hand limit x approaches to say that a minus for the function becomes equals to limit x approaches to this a plus fx, both are equal, then we say limit exists at that x equals to a. Even though we are not able to find the value at that point, don't worry, we are just looking in the neighborhood only. We are not looking at that exact point. Okay, so we have seen how to find the limit of a function using this graphical method as well as this tabular method. Okay, consider this function limit x approaches to 3, x squared minus 9 over x minus 3. This is to be calculated. Okay, so you can simply draw the graph for this function and check it what is the value, because here if you substitute x equals to 3 directly here, what do you get? 3 squared minus 3 over 3 minus 3, which is what? 0 by 0. Means we are not able to find the value at that point. So we will draw the graph. There is a hole at exactly 3, but yes, we can see in the left or in the right neighborhood of that point, the value is around 6 only. So simply we'll say the limiting value of this function is 6 from this graph. Okay, if they gives you limiting function and says find the value of this limit using the tabular method. So you can use your GDC. For example, limit x approaches to a very large number, x approaches to infinity. So you cannot directly substitute infinity in that GDC, right? So you have to choose a very large number. For this function, x plus 1 over x. So this is your fx that you can use in your GDC. Okay. So go to the spreadsheets, enter these following values of x starting with 1, 10, 25. I'm increasing the values here. I can, as you can see, I'm taking a very large number over here. But if you see in this table, the answer is tending towards what? 2.71827. Okay. So here you can say, because you have to write your answer correct up to three significant figures. So you can say 2.72 is the limiting value for this 1 plus x, 1 plus 1 over x raised to the power x function. Simple. So you can find the limit of the function using these tabular or the graphical method. Okay. Let's say we have to solve the following questions. The graph of p of x is already given to us and each cell is one by one. Okay. So here, if I say find the value of p of, let's say 1, okay, it means I have to substitute x as 1. So what is that? Say x equals to 1, starting from this point, it is origin. So x equals to 1, the value is over here, okay, which is 2 units. So from the graph, yes, we can always find the values. Now let's find the limiting values. First part, limit x approaches to 2 minus. Minus means left part, okay. So 2 slightly less than 2 for the p of x. What is that? Go to x equals to 2, 1 and 2, slightly less than that. So what is that? The answer is tending towards infinity. As you can see, this branch, right? This branch. So I'll say it is not defined. Not defined. Because this is tending towards infinity. Next, 3 plus. So go to 3, 1, 2, 3. At this point, means now at this point, take the, you can pause the video and you can try these questions, okay? So here is the answer, right? Around here is the value. So what's that answer? For this one, this is the origin 1, 2, 3. I'm reaching towards negative 1. Similarly for exactly 3, again exactly 3, value is defined at that, which is coming out as negative 1. Why? Because when x approaches to 3, in the left neighborhood as well as in the right neighborhood, values are approaching towards negative 1. I'm not looking at 3 only. I'm taking the value when they are not giving any plus or minus. It means you have to check both left as well as right. Okay. Negative 5 means 5 negative, sorry. 5 negative. So look at the number which is slightly less than 5 only. Okay. So 1, 2, 3, 4, 5. Slightly less than 5. So this is 5 and slightly less than that means here. This point. And at this point you can see the value is tending towards positive 1. 5 plus, what is that? Over here. So value is tending towards negative 1. So if in this question they says find the limit x approaches to 5 for this p of x function. So your answer will be does not exist. Why? Because in the left as well as in the right neighborhood of this 5, I'm not getting the same value. Okay. Now limit x approaches to negative 1. Negative 1, go to negative 1, check for the left as well as right. Okay. So x equals to negative 1, here is this point. So the value at that point is not defined. It doesn't matter. But we just need to check the neighborhoods only. So at x equals to negative 1 in the neighborhood, both left or right neighborhoods, the value is tending towards 0. Y value tending towards 0. So I hope you got all these. Please make sure that you understand everything. If you have any doubt in this, feel free to connect with me. Okay. So I'm giving you these two homework questions that you can try all by yourself. Okay. One from the tabular method and another from the graphical. Now, some analytic methods to find the limit of a function. Okay, so always you have to start with the direct substitution. There are various methods by which you can find the limit of a function. Some of them are like direct substitution always go for this first, or factorization, or rationalization, or trigonometric functions, logarithmic functions, exponential functions, L'Hopital's rule. There are various methods for that, okay, that we have to discuss. Okay, so let's start with direct substitution method. So a problem is given to us. It says evaluate the limit of this fx is what? X squared minus 4x plus 9 when x approaches to 2. So directly substitute x equals to 2. This time we have to use analytic method. I'm not using graph. I'm not using table for this one. Okay, GDC is not allowed, let's say. So substitute x equals to 2 over here directly. So what do you get? 2 squared minus 4 times 2 plus 9. Is it an indeterminate form? No, we are getting our answer directly. So what is that? 4 minus 8 plus 9, which gives me 5. So yes, this is the value. Okay. Now, next one is pi by 2. When x approaches to pi by 2, so directly substitute that. What do you get? Pi by 2 divided by half, right? So, times cot of 3 pi half. What's cot 3 pi by 2? This value is tending towards 0. So what you are doing? You are taking pi by 4, multiplying it with 0. Obviously, you will get 0 always, which is a well-defined number. So this time, this is your answer. You don't need any analytic method, any other method to solve this one, or you don't need graph, or you don't need table for this one. But let's consider another situation where it says limit x approaches to negative 1, right? X squared minus 3x minus 4 upon x plus 1, the same question that we started with. We have seen its answer is negative 5 using graphical method as well as tabular method. Let's do it with analytic method. So here direct substitution is not working because when I substitute x equals to negative 1 and I'm getting 0 in the numerator, 0 in the denominator. Okay, so we need to go for the next method, which is, yes, you are right, factorization. So let's factorize the numerator part. It's a quadratic, so we can simply use the factorization method for doing this. So it gives me factor says x minus 4 and x plus 1. Now x plus 1 can be cancelled out from both numerator and denominator. Let's do it. We will get limit x approaches to negative 1. You have to write as it is always. Okay, and this divided by x minus, sorry, this x minus 4. Okay, so x minus 4 means now let's try again. Substitute x equals to negative 1. So what we get? Minus 1 minus 4, which is minus 5. So yes, this is my answer. Let's do one more. It says evaluate limit x approaches to 7 for this function. Okay, root of x minus 3 minus 2 divided by x minus 7, and we have to substitute x as 7. So directly substitute x as 7. What do you get? 7 minus 3 inside the square root minus 2, which is what? 2 minus 2 means 0 in the numerator, divided by 7 minus 7, which is 0 in the denominator. So it is 0 by 0. It means that's not my answer. We need analytic approach to solve this if possible. So here comes the next method, which is rationalization method. Whenever you have square root, perform the rationalization. So we have to multiply and divide by the conjugate of this number. So I will just multiply and divide by square root of x minus 3 plus 2 over this same. Okay, so let's write it like this. Now simplify it. Just simplify it. A plus b times a minus b identity I can use. A minus b times a plus b. So a squared minus b squared, that gives me x minus 3 minus 4 whole divided by keeping the denominator as it is. Okay. Now this is x minus 7, right? And x minus 7 is also present in the denominator. So I will just cancel out these two in the next step, right? So x minus 7 gets cancelled with x minus 7 in the next step. And I'm left with what? 1 over square root of x minus 3 plus 2. This cancelled, right? Now try one more time. Substitute x as 7 again. So when you substitute x as 7 here, you will get square root of in the denominator, okay? 7 minus 3 plus 2. So root 4 is square root of 2. So 2 plus 2, 4. 1 by 4 is the answer. So this is analytic approach to solve a problem. Okay. So now in this session, I have covered like limits and its notation, limits from the graph, limits from the table, right? And we have seen some algebraic methods to find the limit of a function. Okay. So that's it for this session. And if you want to connect with us, you can directly contact me on this number, as you can see, using the WhatsApp or the Telegram. Okay. So this is my number. You can connect with us for the one-to-one tutoring, or you need regular course, or is there any group session? Okay. So bye bye all. See you in the next session with our next topic. Keep watching, keep learning.